Now that you're familiar with the basic environment setup, it's time to discuss your primary artifact, which is your DAG, and the operators you are using to call whichever services you want to send tasks to. First, Airflow workflows are written in Python. You only have one Python file for each DAG. For example, here we have a simple load.dag.py in our DAG folder inside of our GCS bucket, and you can see a preview of what the DAG file looks like here. Don't worry about reading the code, we'll go into that later. It's sufficient enough to know for now that there are a series of user-created tasks in each DAG file that invoke predefined operators. Take, for example, this task, which uses the dataflow Python operator and is given the task ID of process, delimited, and push. We'll go over creating a DAG file and its components a little bit later. Once you've uploaded the Python file to the DAGs folder, you can then navigate back to the Airflow web server, and under DAGs, you'll see the DAG you just created with code visually represented as a directed graph, nodes and edges. You'll remember that the Python code that defined a task that we called process, delimited, and push is now a node in our graph here. Let's explore a bit more of the Airflow web UI. You can see that this particular workflow is called GCS to BigQuery triggered, and it has 3 tasks when it runs. Number 1, process, delimited, and push, which I just happened to know from that Python file you saw earlier that this task involves a dataflow job to read in a new CSV file from a GCS bucket, process it, and write the output to BigQuery. Number 2, success move to completion, which then moves the CSV file from an input GCS bucket to a processed or completed GCS bucket, a separate one for archiving. Or number 3, if the pipeline fails part of the way, the file is moved to the completion bucket, but tagged as a failure. This is an example of a DAG that isn't strictly sequential. There's a decision made to run one node or a different node based on the outcome of the parent node. That's how you get a branch. Now, this is just an example DAG. More complex DAGs, like the one that you're going to build for your recommendation model, will have more tasks as part of your graph. Take this new DAG, which has 2 BigQuery tasks, 1 ML Engine task, and 1 App Engine deployment task. This is a preview of the last lab, where you're going to be building your own recommendation system. Regardless of the size and shape of your workflow DAG, one common thread for all workflows is the common operators that are used. If the DAG itself is how to run the code in the workflow, first do step 1, then move to step 2 or step 3. The operators specify the what that actually gets done as part of the task. In this simple example, we're calling on the dataflow Python operator and the general Python operator. Those are by no means the only operators, so let's pause here and look at all the operators that are at your disposal to achieve our goal of automatic retraining and deployment of our ML model. Airflow has many operators which you can invoke to use the tasks that you want to complete. Operators are usually atomic in a task, which means that generally you only see one operator per one task. I've taken this list directly from the Apache Airflow docs of all the services that Airflow can orchestrate to. Let's take a look at some of the ones that are common and most relevant to us as ML engineers. As you might have guessed, we'll certainly be making use of the BigQuery operators, since our workflows live and die by the data that's fed into them through GCS and BigQuery. Here's a list of the specific operators that we can invoke in a task to call on the BigQuery service for querying and other data-related tasks. You'll be mainly working with the first 3 in this course, but I encourage you to skim the resource link on all the operators that you can use so you can get a feel for everything that's possible. Once we have our training data in a good place, the next logical step in our workflow is to then retrain and redeploy our model. In the same DAG file, after the BigQuery operator is complete, we can then make a service call to a Cloud ML Engine operator to kick off a new training job and manage our model like incrementing the version. You might have noticed that your Airflow DAG can have operators that send out tasks to other cloud providers. This is great for hybrid workflows, where you have components across multiple cloud platforms, or even a combination of cloud and on-premise. Apache Airflow is open source, and it's continuously adding more operators to other services, so be sure to check out the list in the documentation periodically if you're waiting for a new service to be added.